Hi, and welcome to this look at an applied formula determination question. Definitely one that needs you to use a problem-solving and deductive type approach. So it tells you actually quite a lot of information in that second sentence. So we know it contains carbon, hydrogen, and oxygen only, but crucially we have quite a lot of data that we can do something with. So what I suggest with this kind of question, because it's to do with a combustion, put together the beginnings of an equation. So notice that I've put n, little n, to represent the number of moles of compound N, x to represent the number of moles of CO2, and y to represent the number of moles of water. So the reason I'm doing this is because the number of moles of carbon dioxide will equal the number of moles of carbon atoms, because for every molecule of carbon dioxide you get one atom of carbon. The number of moles of water that I get will be half the number of moles of hydrogen atoms. So I want the moles of hydrogen atoms and the number of moles of carbon atoms so I can piece together how many there might be in 1 mole of N. So looking at the pink data, you've got 1.71 over 76. So that must mean that the number of moles of N in this particular sample is 0.0225. Taking a similar approach for carbon dioxide, you get 0.0675. And doing it again for water gives you 0.09 moles. So let's clear the screen and collect that data. If we divide each of them by the smallest, like so, you'll get a whole number ratio. So we can take something from this now as well. We can update our equation. So 1 mole of N, our compound N, must contain 3 moles of carbon atoms and 8 moles of hydrogen atoms. Remember from before, if you look at water, there are 2 hydrogen atoms in a water molecule. So 4 water molecules must contain 8 hydrogen atoms. So let's start with C3H8O. We know that it contains carbon, hydrogen, and oxygen. We know that its MR is 76. So doing a quick check, you end up with 60 grams per mole if you just use C3H8O. But if you take 60 away from 76, you've got 16 left. So obviously there's another oxygen atom. So now we've got something that matches the MR we're provided with. Now in terms of suggesting a structure, it's important to look at the command word. It says suggest. It doesn't say what is the structure. There might be several options that could work. So at this point I'm going to share the mark scheme with you so you can see how far we've got. So we've got all the points for the data crunching, points 0675, 0.0900, the correct ratio of carbon to hydrogen, the molecular formula, and any correct structure. So it's interesting, they don't actually specifically say any one. So anything that matches C3H8O2 would be accepted here. Obviously you'd have to have 4 bonds on your carbon, 2 bonds on every oxygen, and 1 bond on every hydrogen. But apart from that, pretty much anything. And the fact they say etc. means that they don't have to specify either of these two either. You could have something else entirely. Okay, hopefully this is a useful look at how you might think your way through those questions, and also as a result how flexible the mark schemes are in a reflection of how demanding the question is to start with. Okay, thanks for listening. Until next time, see you soon.